For number 14, we're trying to see how the weight of a car would affect the car's gas mileage, trying to see if there's any correlation between those values. I'm going to do it in Excel, so you copy it to a clipboard. You can use StatCrunch if you want, but I'm just going to use Excel. You paste it in Excel, and it'll show up like this. And then if you go to Insert a Scatter Plot, shrink that down so it's easier to look at. You can click on the data points here, and if you right click, you can add the trend line, which will be the least squares regression line. So it adds the line in there for you. You have some options over here on the right to add the equation right there on the chart. So when you do that, you'll get the equation for the least squared regression line shows up right there on your chart. And that's actually what you want to use for your value, or for your answer to part A. Part B is interpreting the slope, and for any line you ever graph, the slope has a similar interpretation. It's the change in the y value for a 1 unit change in the x value. So since our y value was miles per gallon, it's the change in the y value for a 1 unit change in the x value. Now the y-intercept would be, where does the line cross the y-axis, which means the x value is 0, which really doesn't make sense because that would mean the weight of the car in pounds is 0. So that's one reason it doesn't make sense to talk about the y-intercept. And also look where our data is. It's really far away from the y-axis, so it's not good to extrapolate that far back outside of your data values. So it's not appropriate to interpret the y-intercept. It's outside the scope. For car D, the predicted value, you need to plug in this weight into this equation here, and that gives you the predicted value based upon our least squares regression line. Now our actual value that we had from our data was 18.5, and the difference between the predicted value you get and the actual value of 18.5 is the difference of 2.24, and we do negative because it's below the line. So if you take that actual value and minus the predicted value, you actually get a negative, and that's because our data point is below the line. And for the final part, pick the scatter diagram that fits the data, has the correct points and the correct line plotted.